All right, you guys, today is the big day to learn our final way to solve a quadratic equation. It's one of my favorite ways because it works 100% of the time, right? And so while I love factoring, solving by factoring, it only works if the expression is factorable, right? And I love the square root method too, but if I have more than one x term, I can't use the square root method, right? So those methods are very limiting. And the graphing method is also limiting, right? Because if I look at a graph and it's not going through a perfect whole number or a nice, pretty finite decimal, well, then I can't round my answers. So the graphing method, factoring, and the square root method, they have their limitations, but the quadratic formula, which is what we're covering today, this lovely thing in this upper right-hand corner, he covers everything, no matter whether it's factorable, whether it's not factorable, if it has 1x term, 2x terms, right? It just works 100% of the time. So it's so amazing. All right. So I just gave an example here, right? If I saw this expression and I tried to factoring, and you guys are so amazing at factoring, right? So you might want to try that all the time because you get really comfortable with it, right? You would sit here and you would try, right, to make our little number puzzle, and you would ask yourself, well, what are the two numbers that multiply to give me negative 20, but add to give me 5? And there just are no numbers that multiply to give me negative 20, but add to give me 5. So I can't solve him by factoring. Okay, so quadratic formula to the rescue. Now, another good thing about the quadratic formula is it works for any quadratic that is written in standard form. Okay, it doesn't work for vertex form. It only works for standard form. This is a very large formula, but you don't have to memorize it because it is on your formula chart. Okay, it's that last little formula that we haven't talked about yet. You'll notice I have these little musical notes off the side. It's because if I were in class today, we would be singing the quadratic formula because it follows perfectly to the Pop Goes the Weasel music, right? Do you guys know that song? Da 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 da. Right? And so while you don't have to memorize the quadratic formula, it's a really great formula to memorize and just to know. And so if you put it to a song, right, then it's a lot easier to remember. So I'm just going to sing it once for you, and you can kind of hum it to yourself as we go through. So it kind of sounds like this. X equals negative b plus or minus square root of b squared minus 4ac all over 2a, right? See there? Yay! It fits perfectly with that little tune, right? And so sing it along to yourself. I'm sure I'll probably hum it along as I'm doing the problems here in a few minutes. All right, before we get too deep into actually using the formula, I want you to notice the plus or minus symbol, right? And that's what's going to give us our two solutions because we've already talked at length about quadratics always having two solutions. And then you'll notice we have this big square root and we have this whole expression underneath. So we're going to take a few minutes and just talk about that expression, that b squared minus 4ac, because it has a special name, right? It's called the discriminant. It's a big word, discriminant. It's highlighted right here in yellow. So the expression under the square root, b squared minus 4ac, is called the discriminant. And it's that number, right, that you get when you plug your A, B's, and C's in. It's that number that tells you how many solutions and what type of solutions your quadratic has, right? So we're just going to talk about that really quick. So if you calculate the discriminant, or b squared minus 4ac, and you get a number that is greater than 0, any positive number essentially, right? So you end up with a positive number. That tells you that your quadratic has two real solutions, right? Two real solutions, okay? And that, of course, means our graph is going to look something like this, right? Not exactly, right? I wanted to give me a nice, pretty parabola. There we go, right? So it's going to cross the x-axis twice is what that's telling us when our discriminant is a positive number, right? We get those two real solutions, okay? If our discriminant is exactly 0, right? That means we have technically one real solution. And you're like, well, Miss Jester, I thought you said every quadratic has two solutions. It does, and we've talked about this before, right? This means it's only touching the x-axis once, right? But technically you are getting two solutions. You're just getting the same solution twice, right? So I'm going to write, this is what we call, we've talked about this before, that this is called a double root, right? So you would get the same answer twice, like x equals 3 and then x equals 3 again, right? You're still technically getting two solutions, but they just happen to be the same number. And that's what a discriminant of 0 tells me is going to happen, right? That I'm going to get the same answer twice. So my parabola is actually only going to hit the x-axis once and then turn back around as soon as it hits the x-axis. Okay, and then our last one is if the discriminant is less than 0, meaning a negative number, right? And remember that b squared minus 4ac is under a square root, right? So you can imagine what's happening is we're trying to take the square root of a negative number if our discriminant is negative. And I don't know if you've ever tried to take the square root of a negative number, but if you put that in your calculator, it's going to give you an error. And it's going to say non-real solution when you type that in, or it's going to say non-real answer, right? And that's because the quadratic has two non-real solutions. Right? It has no real solutions. It still has two solutions. They're just not real numbers. They're actually imaginary numbers, right? Which you'll learn about when you take Algebra 2, right? So there's still two answers, but this parabola is never going to dip low enough or high enough, right? It could look like this also, right? Where it's facing, oops. Oh my goodness, what's happening? It's facing downward, but it's not coming up high enough to reach the x-axis, right? I'm just going to erase that. And or it's not coming down. It still technically has two solutions, but not in the real number system. Okay, so we won't have to worry too much about that. You'll talk a lot more about that when you get to Algebra 2. Okay, all right, so basically we're just going to use this wonderful x equals negative b plus or minus square root b squared minus 4ac all over 2a. Right, we're going to use this lovely formula, and we're just literally going to find our solutions for x by plugging our numbers in. Okay, so the steps have been written here for you, so you can kind of just follow along with the steps. Essentially, step number 1, like we've been talking about before for all the other ones, your equation has to be set equal to 0, and it has to be in standard form. So this guy is good to go. Now, once you have it set equal to 0, and you know it's in standard form, right, ax squared, here, I'm going to write that up here, right, ax squared plus bx plus c, the first thing you really want to do is be able to identify correctly your a, b, and c values in your equation. So hopefully we can all see that the a value is 3. The b value is -1, right? Because there's an understood 1 right here. And then the c value is also -1. All right, so here we go. That's really all you need is your a, b, and c values, right? And then you are just going to type it all into, or just substitute it all into the quadratic formula. And then once you've created this big mess of numbers, you're just going to take a few steps to clean it up. Okay, so here we go. X equals -b. So b is already -1. I'll go ahead and write all my little steps though. But -b, hold on, you know what? Let me go grab this guy. Oops. Copy. I'm going to bring him down here. Paste. Oh my goodness, y'all. There we go. All right. I'm going to put my little formula up here. All right. Here we go. So x equals, so notice it says -b. So negative, but my b is already -1. So you could just put +1. Plus or minus square root of b squared, I'm going to put it in parentheses, b squared minus 4 times a times c, which is -1. 2a, hold on, make it a nice straight line. All right, so all over 2 times a, there we go. Whew, that's a lot going on there. Hold on, let me fix this line because it's going to bug me that it's crooked. Okay, there we go. Now we need to start cleaning stuff up, right? So the first thing I would like us to do is, I don't ever want you to type in the square root in your calculator yet, because if it's not a perfect square, then you're just going to have to go back and redo it all by anyway. So the first thing we want to do, I'm going to bring down my x equals, here's my fraction bar. The first thing I'm going to do is I'm going to type all of that yellow into my calculator, right? And I'm going to get that number and simplify it and bring it down here, okay? Oh my goodness gracious. Make an arrow. There we go. Okay. So in my calculator, and please put all those parentheses in there or you're not going to get the correct answer, right? So parentheses, -1 squared, try it with me, -4, make sure you put a minus sign for -4. Don't use a negative. As you make sure you use the negative and the minus signs as you read them out loud, which sign you would say if you were reading this to a friend. So -1 squared, -4, parentheses 3, parentheses -1. And I'm getting 13. So all of that simplifies into the square root of 13. That is our discriminant. Notice that is a positive number. So if you recall up here, if your discriminant is positive, right, we know we're going to end up with 2 real solutions, which is nice. All right, now I'm going to simplify everything else. So I've got my plus or minus still in front. I've got my -1, which is a 1, and then 2 times 3, which is 6. Okay. Now, if you can simplify your radical, you need to, right? But clearly, if I try to go off to the side and make a factor tree for 13, 13 is a prime number, so his only factors are 1 times 13. So there are no pairs in that square root that I would be able to simplify, right? And so that means that this is my final answer. I can't do anything else with this, right? And I know that looks really weird because we're not used to seeing answers that look like that, but technically these are my 2 solutions. If you want to, or we could also write this as, and I know this is going to look kind of crazy, 1 plus the square root of 13, because my first answer is using the plus sign, divided by 6, comma 0, right? Remember that's an x-intercept. And then my other solution is 1 minus the square root of 13, all divided by 6, comma 0. Right? And so those are my 2 solutions. And I know those numbers look really gross with all the pluses and minuses and the square roots and stuff, but that's because my answer is irrational and they're gross decimals that go on forever and ever and ever, right? And so that's just going to happen. Okay. All right. You can check your answers in Desmos, but that takes a little bit of work because you're going to have to type in 1 plus the square root of 13 divided by 6. So let me see, 1 plus the square root of 13, divide that whole thing by 6. Again, I'm not going to go this in depth on every problem. So this is approximately 0.76 76 ... That goes on forever and ever and ever, right? And this one, 1 minus the square root of 13 divided by 6. I would use fraction mode if I were you. That is approximately negative 0.4343 ... right? And you could go into Desmos and type in this question, 3x squared. Let's just do it really quick. We may as well for this first question. 3x squared minus x minus 1. Here we go. Oops. All right. 3x squared minus x minus 1. Kind of zoom in there. There's my parabola. And look what happens when I click on my zeros. Looky there. Negative 0.434 and positive 0.768, which are the rounded decimals to 3 places of what we just got. Okay, so you can check your answers, but it just takes a lot of effort because you got to type in your calculator to figure out what the approximate decimals are and so on and so forth. Okay. All right, so check on Desmos. Okay, but again, the final answers that we want, right? I want this as your final answer right here. If you want to split it up and write it as these two separate ones, then you can. I'll take it either way. All right, let's go try another one. Here we go. Hopefully you'll notice what's wrong with this guy is that he is not set equal to 0, right? And with standard form, it doesn't really matter if your a or your x squared term is positive or negative, but just to kind of keep things consistent, I'm going to move these terms over to join my 2x squared. So I'm going to add my 2x, and I'm going to subtract my 1. And I do want to make sure I put it in that order because I want it in standard form. And now that I have that, I'm going to make sure I notice that my a is 2. My b is also 2, and the c value is negative 1. So now that I have my a, b, c's, I can start plugging into my quadratic formula. Here we go. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. There we go. There's our big mess of a's, b's, and c's. So now it's just up to you to clean up the mess. So the first thing I always like to do is type all this in my calculator, or you can do it in your head, right? So it's negative 2 plus or minus the square root of some number all over 4, right? Because 2 times 2 is 4. So I'm going to type that in my calculator. 2 squared minus 4 times 2 times negative 1. I'm going to put all those parentheses in there so I don't make a silly parentheses mistake. And I'm getting 12. All right. Now remember up here, we got 13, but 13 was a prime number, right? So we couldn't simplify the radical, right? But on this one, let me just go ahead and kind of, there we go. Right, I'm definitely going to go off to the side and see if I can simplify the square root of 12, which I totally can, right? And when you notice that you get a pair of 2's, all right, there we go. So we definitely have a pair of 2's that we can take out. So my answer actually becomes, I'm going to bring everything else down, negative 2 plus or minus. But my square root of 12 is going to become 2 square root 3, and then all over 4. Okay, so we simplified the radical, right? Now you might be thinking, okay, well, I'm done because we simplified the radical. But you got to hold on. Now at this point, remember when we have fractional answers, we always want to see if our fractions are reducible, right? So in this case, we want to see if our fraction is reducible. Now, I can't touch the square root, right? Square roots are like math prison, right? You can't touch the number under the square root at all. But what I'm looking for is the 3 other numbers, the ones that are not trapped in a square root. So you want to look at those numbers. I guess I should put the, hold on, let me make sure I'm putting the negative in there with the 2. There we go. We want to look at these 3 numbers that are not trapped in the radical and ask if all 3 of these green numbers can be reduced to by the same number, right? So is there a number that will go into 2, 2, and 4? And I'm hoping you're thinking, yes, Ms. Jester, right? I can divide all of those by 2, right? And so if I divide them all by 2, 2 divided by 2 is 1. 2 divided by 2 is 1. And 4 divided by 2 is 2. Now, if all three of these were not divisible by the same number, then you wouldn't be able to do anything to the problem and you would be done, right? It can't be like 2, oh, well, I can reduce 2 out of the 3. Nope. It's all three numbers or it's nothing, okay? And so my final answer then is -1, because don't forget about the negative, right? I guess, let me actually put the negative up here because I'm technically dividing -2 by 2. Plus or minus 1 square root 3, which you can write the 1 if you want to, but 1 times the square root of 3 is just the square root of 3, and then divided by 2. And those are our two solutions, right? Again, I know it doesn't look like two solutions, but that plus or minus is giving us the two solutions. So I could also write this as -1 plus the square root of 3 divided by 2, comma 0, right? That's the first x-intercept. And my second x-intercept would, of course, be -1 minus the square root of 3 divided by 2, comma 0, right? So it is two totally different answers, right? But I would have to type that in my calculator, right, to get those gross irrational decimal answers, right, which I don't really want to ever do unless you're trying to check your answers in Desmos, right, to see if you have done your quadratic formula accurately. Okay? All right. I'm literally just going to sit here and do lots more examples. So here we go. The first thing that jumps out to me about this problem is that it's set equal to 0, which is awesome, but it is not in standard form. So I definitely need to get that negative x squared in the front and kick that positive 48x term to the middle. I'm not moving anything to the other side because I'm already equal to 0. And again, in quadratic formula land, it's okay for my x squared to be negative. If you want to move everything to the other side to make the x squared positive, you certainly can. You're going to get the same answer at the end. It's just not necessary for quadratic formula like it is when we factor by grouping. All right, so now that I have it in standard form, I notice the a value is -1, the b value is 48, and the c value is positive 100. And once I have those lovely numbers, I can throw them into my quadratic formula. So here we go. Shall we sing the song? X equals -48 plus or minus square root 48 squared minus 4 times -1 times 100. That didn't really flow very well. All over 2 times -1. There we go. Oh, those are some big numbers. That's a big mess, but that's okay. Just take it one step at a time. And step number 1 is to put all this in your calculator, not the square root, just the discriminant, right? Just the stuff that's underneath that square root. And I like to go ahead, I'm going to write all this out. -48 plus or minus square root. I'm just going to put a little empty square root. And then, of course, 2 times -1 is -2. We can just do all that in our head. Now, what you're not allowed to do, right? Don't try to reduce those guys. Remember, we learned in Unit 6 that you can't cancel terms, right? You can only cancel factors. So be really careful. All right, I'm going to type all that mess in my calculator. 48 squared minus 4 times -1 times 100. And I'm getting 2,704. All right, so that's a really big number. And if I were you, before you go off to the side and start making a factor tree for 2704, because it's such a big number, I would check to see if it's a perfect square or not, right? So on my calculator, I'm going to go ahead and type in the square root of 2704, right, to see if it's a perfect square. If it is, it'll just give me a whole number, obviously. And if it's not, I'm going to get a gross, irrational, never-ending decimal, right? If it's a never-ending decimal and it's nasty, then I'll have to break it down by hand. But hopefully you've already done this and you typed it in, and you will notice it is a perfect square, right? 2704, I'm just going to kind of write it like this, is 52 times 52, right? So he's a perfect square, right? Perfect square. And you don't have to write this part down, right? It's just reminders in our notes, right? Which means that's awesome. That means I don't have a square root in my answer anymore. So it's negative 48 plus or minus 52 divided by negative 2. Now, the cool thing about perfect squares is we can actually get nice, pretty answers and not have to leave it looking like this mess, right? So here we go. We're going to break this up. I'll use orange, right? Or I guess pink. I'm going to split this, right? One of my solutions is negative 48 plus 52 divided by negative 2. And the other solution is negative 48 minus 52 divided by negative 2. And you're going to want to type those in your calculator totally independently because they're going to give you two completely different answers, right? And so for this one, we're going to get x equals, please use the fraction mode on your calculator, right? Go to alpha y equals and hit enter. Because if you just type it in your calculator like this, divided by negative 2, you're going to get the wrong answer. Because your calculator is going to do the division first and then add because it's programmed to do the order of operations. So please use the fraction mode on your calculator so you don't mess up at this point. So negative 48 plus 52. Then in my denominator, I'm going to put negative 2. And my calculator is telling me negative 2, which makes sense because the top gives me positive 4 divided by negative 2. All right, so that's one of my answers. You could also write that as negative 20 if you want. I'll take it either way. All right. All right, and we're going to get another solution over here when we type in, again, fraction mode, negative 48 minus 52, and the denominator negative 2, and that's giving me positive 50. Or you could write that as 50, 0. I'll take it either way. This would be an awesome opportunity because our answers are nice, pretty whole numbers, right? To go check it in Desmos by typing in that original function up there, right? And then seeing, you'd of course have to shrink your screen a little bit so you could see that 50. That's going to be way off of your home screen, right? So you should be getting negative 2 and 50 though. All right. Let's keep going. Looks like we got 3 more examples. If you're feeling confident, then you can probably stop and go work on your homework. But we're going to talk about some special cases here, like number 4, for example. You'll notice he's missing his x term, right? So as far as ax squared plus bx plus c, right? He's got his x squared term and he's got his constant c term, but he doesn't have the b term, which of course means the a is 1, right? The understood 1, that's in front of the x squared, but the b is 0 and the c is negative 18. So just be careful, right? When you're doing quadratic formula, you can have zeros for your b and your c. You can't, not for your a though, of course, because you have to have an x squared term to be a quadratic, right? But you can definitely plug in zeros and it still works out just fine. All right, here we go. So x equals negative b. Now, technically that's negative 0, which means nothing. So we'll just take that off in a second. Plus or minus square root of b squared minus 4ac, right? All over 2a. There we go. And it's just the same steps over and over and over again. All right, so I'm going to take all that stuff. If you want to keep the 0 in there, you can. I'm going to take off the negative, though, because clearly 0 is not positive or negative. So you could also just leave it off. It's very redundant to be in the front there. I'll take it off here in a few minutes, though. I don't want to do it right this second. So 0 plus or minus, oh my goodness, I just want a straight line. There we go. All over 2. All right, so I'm going to type all that in my calculator, right, and get whatever number that's supposed to be that discriminant underneath the radical there. So here we go, 0 squared minus 4 times 1 times negative 18. And I get positive 72 under here. And you can check on your calculator if you can take the square root of 72, but when you do, it's going to give you a never-ending decimal, so that doesn't do us any good. But we do want to see if 72 is simplifiable, right, as a square root, right? So let's see, what if I do 3? You can break it down however you want, right? It does not matter, right? So if I divide by 3, I get 24. And if I divide by 3 again, I get 8. And then 2 times 4 and 2 times 2. We've done 72 a couple times before, right? And again, if you can do your square roots in your head, then that's great. And remember, we only look at the primes at the ends of our branches. Once we break a number down, we don't look at them anymore, right? So if you need to like cross the numbers off as you go, you can. All right, and then we're looking for what we have pairs of. I definitely have a pair of 3s and a pair of 2s. So here we go. We're going to end up getting, now I'm just going to take the 0 off because 0 plus or minus anything is just that, anything. So the 0 doesn't have any merit on our answer here. So 0 plus or minus, we can take out a 3 and a 2, which is going to give us a 6. And then we have that lonely little 2 that didn't buddy up, so he has to stay inside, all over 2. All right, and remember, we need to reduce the fractions if we can, but we only care about the numbers on the outsides of the radical. We cannot touch that 2 that's inside the square root, right? He's protected by the square root. We don't have a number out here because it was just 0, so I just care about the 6 and the 2, which I can totally reduce by 2, right? And so, oops, sorry. So if I reduce those by 2, sorry, I'm going to erase the green, right? This is going to turn into a 3, and 2 divided by 2 is a 1, right? So our final answer is plus or minus 3 root 2. And you can, I don't need the 1 in the denominator. You can put it if you would like, right? But there's no need to write that denominator if it's a 1. Right, remember that is technically 2 different answers. That's 3 root 2 comma 0 if you want to write it like that. And it's negative 3 root 2 comma 0. Right, so you can always give those answers like that if you want to. All right, let's throw in just a couple more and then we'll be done. All right, so let's go look at this guy. So he's definitely not set equal to 0. You can move the terms in standard form. You can move them wherever you want. I'm just going to go ahead and pick up this positive 49 and move it over here. So that's going to give me 0 equals negative x squared minus 14x minus 49. If you want to take everything to the other side so that your x squared is positive, right? And so you want to add the x squared and add the 14x, that's totally fine. We're all going to end up with the exact same answer, right? Because what's happening is my parabola, whether it's opening down or whether it's opening up, I don't really care. I care about the solutions, right? And they're going through the same x coordinates, whether your parabola is positive or negative. Okay, so that's why it doesn't really matter which side you take it to. Okay, so let's see here. We've got an a value of -1, a b value of -14, and a c value of -49. That's a lot of negatives. Like I said, if you don't like all the negatives, move them all to the other side and make them all positive. All right, so here we go. X equals -b. Right, my b's already negative, so a -14 would be a positive, plus or minus square root of -14 squared minus 4 times -1 times -49. need a much longer fraction bar. There we go. All over 2 times -1. All right. I feel like a broken record, right? It's the same steps over and over again just to simplify this mess. So I'm going to kind of write my little template here. Bring down, obviously 2 times -1 is -2. So what I want to do is snag my calculator and type in this discriminant, all right, to see what number I get underneath that radical. There we go. Don't forget your parentheses. Here we go. Parentheses, -14 squared minus 4, parentheses, -1, parentheses, -49. Ooh, I'm getting 0. All right, I'm getting 0. That's interesting. We talked about this, right? Do y'all remember right back here? What happens if the discriminant is 0? That means there's only one solution, or it's technically a double-rooted solution. Let's go see what happens. All right, so here we go. X equals 14 plus or minus. Now 0 is a perfect square, right? Because 0 times 0 equals 0. So the square root of 0 is 0. You can use your calculator if you want to. And so we can actually do this math problem, right? I'm going to kind of break this down. All right, my first problem is 14 plus 0 divided by -2. And our other solution is 14 minus 0 divided by -2. And you'll see what's happening is we get, because you're just adding or subtracting 0, the 14 never gets altered, right? So no matter what, it's 14 divided by -2, which is -7. And I get the exact same answer over here, right? And so this is a double root. Oops, where'd my 7 go? Because we got the same answer twice, right? And so we would just say that the answer was -7 or -7 comma 0 if you want to write it like that, right? It technically is 2 solutions. They just happen to be the same one, right? So that means our parabola, right, or my parabola, because I kept it negative, is going to be doing this, right? It's only going to hit that x-axis once up there. Okay? All right, let's do one more. See what happens with this very last one. All right, definitely not in, it's not set equal to 0. I'm going to keep my 3x squared on the left where he is, and I'm going to bring my positive 3x and my -2 over. So my 3x is going to change to a negative, and my 2 is going to change to a positive because I'm going to be adding them to him to the other side. Remember, terms just change sign when you carry them to the other side. All right, so now that I have that, I know my A is 3, my B is -3, and my C is +2. And again, it's the same steps over and over again. So here we go. X equals -B, but my B is already negative, so -3 would be +3, plus or minus square root of b squared minus 4ac all over 2a. There we go. All right, so let's see what we got. 3 plus or minus the square root of something, which I'll type in my calculator in just 1 second. And clearly 2 times 3 is 6. All right, so now I'm going to reach for my calculator. I'm going to go type that discriminant in, right, and figure out what number that gives me in here. Oops. There we go. All right, here we go. Parentheses, -3 squared minus 4 times 3 times 2. Uh-oh, I'm getting -15. Now, if I try to take the square root of a -15, right, it's going to tell me an error because I can't take the square root of a negative number in the real number system. So this is no real solutions. And that's what you're going to put as your answer. okay? Because I can't take the square root of a negative in the real number system. Like I said, when you get to algebra 2, you'll learn how that works and what's happening there, right? But we just need to know, right, in algebra 1, we just need to know that if we go to Desmos and we look at the graph of this thing, I don't know exactly where its placement is necessarily, right? But I do know, it's looking something like this-ish. It could be off center, I don't know, right? But it's never going to be able to get down low enough to reach that x-axis, okay? And that's what that no real solutions is telling us, okay? All right. I hope you've liked the quadratic formula. It's one of my favorite formulas in Algebra 1, right? Just make sure you're simplifying as much as you possibly can, and always come back and look at these examples, right, if you need to for your homework. All right, guys, I will see you in class soon. Come back to class with any questions, okay?